function. For those of you who have done admins, this is something you've seen before, except that you may not have seen the domain part of the composite function, but you've learned how to form a composite function. So let this be a revision for you. Otherwise, it will, for those of you who did not take, then it will be something new. Okay, so what is composite function? Composite function is actually a function. You're going to add a function into another function. So given two functions f and g, the composite function denotes by fg. It's okay, I just write f composed by g is defined by fogx, fgx. All right, what does it mean? We are going to change all the x into gx. All right, the domain of fg is a set of all numbers x in the domain such that g domain of g such that gx is in the domain of f. Now, of course, when you read this definition like this, you won't understand what it means. Okay, what does it mean is, let's say, if we had a function fx equals to 2x, all right, and then we had another function gx equals to, let's say, 4x, all right, just make a simple one. So if I say what is f1, what you do, you take 2, multiply by 1, and then you get the answer, correct? So what you substitute here, the x value here is what you put into your function. So if I say f2 equal, then you say 2 bracket 2 will give me a 4, correct? If I say x equals to 3, that means you're going to change to 3 equals to 6, and so on. But what if I give you fgx? So if I give you fgx, which means now all your x now must be changed to gx. So your x here now must change to gx. All right. So it becomes 2. What is your gx? 4x. Take and then put it in 4x, and then you get another function. So this is called composite function. So don't worry about the sign O here, this hollow dot. I am going to give you the same way as you did your SPM. SPM, we did fgx and gfx, right? All right. So we are going to do this way. All right. We're going to do fgx, gfx, which means a composite function. All right. Now, this is just the simple part. This is a simple part just to tell you what is composite function. Composite function is putting a function into another function. Putting one function into another function. That's called composite function. Okay, so let's look at the first one here. Now, suppose that fx equals to 2x squared minus 3 and gx equals to 4x. Find fg1. Okay, before you find fg1, before you find out what is fg1, I want you to do this first. I want you to find out what is fgx first. Okay, so what is fgx? So I know fx equals to 2x squared minus 3, correct? So if I want fgx, that's what I want, fgx, fg. So fg, that means I'm going to take g and put it into my f, which means all my x now will change to gx minus 3. Then 2 gx squared is now, gx is 4x squared. 4x squared minus 3. So this is the function. Now what they want you to do is now change your, so this is your fgx now. Fgx equals to, multiply 16, 32 x squared minus 3. Okay. So now they want you to find fg1. So what do? You substitute now all the x here by 1. So 32, 1 squared minus 3. So it becomes 29. Okay. Okay, let me show you few. There's 4 examples here. So by the time I finish the 4th one, you should be able to get the answer correct. Okay, you should be able to do it already. Now part B, they want GF1. So before you find GF1, I want you to find out what is GFX first. So what does gfx mean? Take fx, put fx into your gx. Take fx and put it into your gx. So gx just now is given by gx is 4x. Now what you're doing is you're going to replace all the x with fx. So now it's going to be 4fx. What is fx? 2x cubed minus 3. So it becomes 2x squared minus 3. 2x squared minus 3. So it becomes 8x squared minus 12. Then, so this one, if I simplify it as gfx. Now what I want is gf. Now my x is going to be 1. So gf1 will be changing all the x's to 1. Here 8, 1 squared minus 12. So the answer will be negative 4. Okay, one more time. I'm going to show you part C and part D. I'm going to erase this. Alright, erase all of this. Okay, so next one, part C. I want f negative 2. So the first step I do is I find out what is my fx first. What does this mean? I'm going to take fx and put it into my fx again. Take fx and put it into my f again. So now this is how it goes. Fx is given as 2x squared minus 3. So if I want fx, all right, that means what I'm going to do is change all the x to fx. So I have here 2fx squared minus 3. So what is fx? So I need to substitute this fx here. Fx now becomes 2x squared minus 3 whole thing squared minus 3. Okay, I can choose to either expand this or leave it as it is. So this function here, now I know f(x) equals to 2x squared minus 3 squared minus 3. What do I want? I want f negative 2. This means all the x value now needs to be changed to negative 2. So you have here 2 squared minus 3 whole thing squared minus 3. So you have, if you solve this, you will have 4, 8 minus 3, 5, 5 times 5 power 2, 25, 25 times 2 will be 50, 50 minus 3 will be 47. Okay, so this is composite function, taking one function and putting it into another function. So let's see the last example. Hopefully by the end of this example, you already know how to do a composite function. All right, so we want to find out gg negative 1. What is the first thing you do? You find out what is ggx first. All right, then what does ggx mean? You're going to take gx and you're going to put it into gx again. All right, you're going to put gx into gx. So this gx, you're going to take and put it into this gx, which both gx are the same. So see how it goes. Gx equals to 4x. So what happens now? My x now changes to gx. This is what I want. I want ggx. So ggx, that means I'm going to change all my x to gx. So I have here 4gx. Then substitute what is gx. Gx is 4x, so I have 16x. So this is my ggx. So they want gg negative 1. So gg negative 1, all the x values need to change now to 1. So you put it in 16. Put in negative 1, you have negative 16.